Hi, my name is Mike Hells, Product Manager from Emerson, working with TopWorx. Today we're going to have a quick overview of using a Foundation Fieldbus DXP device from TopWorx together with a TREX from Emerson. So first of all, we need to connect the TREX device to the Foundation Fieldbus ports on the top of the TREX, ensuring that we use the additional connector to connect power. Then we must ensure polarity is correct by making sure that the red is connected to the red lead, which is the positive side of the Foundation Fieldbus connection. Now we're going to initiate the field communicator device application on the TREX. We're selecting Fieldbus and we're also selecting powered from the TREX. When you initiate it, first of all, you'll notice that the address is 251. This is a temporary address that has to be changed. In this instance, we're changing it to the number 34. There is a number of parameters from 25 to 35 that you can use. In this case, we're changing to 34. In any changes, what it needs to do, it needs to poll directly to the device and then back to the TREX. So there is a little lag in this period. And as you can see now, it's disabled the 251 and enabled the 31, but immediately it's not available because again it has to poll the information and it has to ensure that it's connected to the device correctly. So as mentioned, this takes a little bit of time. So we see the egg timer moving now so that we know that the device is connected and it just needs to get to the next stage. So now, for those who are familiar with the AMS device or other TREX instrumentation, the screen HDMI or HMI is exactly the same. So what we're going to do is we're going to calibrate the device. A common feature when you're initializing or testing any of the Foundation Fieldbus devices, and calibration is needed, especially on a rotary device. So now what we have to ensure is with this particular device, we're going to go to the open position. There's a dead band on our transmitter, so we're just ensuring that it's the right way round. We can obviously move our devices to make that fit. So we're selecting the open position and we're ensuring it's not within the dead band. The dead band is indicated by two red dots, and that area is not able to be selected. We're now connecting to the closed position. So now we're configuring the open and closed position and we're setting that, and as you can see, the calibration is finished successfully. This is allowable range. This is to calibrate between the open and the end position, so we can have a percentage there where it can be a small percentage out if you need that parameters being set. And now we're being asked to fill in the calibration information, and again this is stored on the device. So in this case we're just changing the date, but you can put a signature on there, a date, you can put any information that you need, and obviously this satisfies some of the requirements that you may have within your quality procedures, and also on site there may be other procedures that you need to satisfy. So the parameters are all set now. And parameters are updated, so it's giving you an indication that the method is complete. And now if we look at the dashboard on the device, again, because what we need to do is we need to poll the information from the device and back again, there is a small lag in timing, just so that the information can be received, it can be registered, it can be inputted on the device. And within Foundation Fieldbus, this is limited to obviously the speed at which the Foundation Fieldbus connects and transmits the information. But generally speaking, for the applications that this is used in, it's not an issue. And this is only a sort of demonstration of the capabilities. So as you can see there, it's obviously registering the analog position in terms of a percentage. So I've just moved it a little bit there to ensure it's 100%. And now we're just going to have a look at some of the other variables that you're likely to change, especially on commissioning. A lot of devices now have a tag number, and these are sometimes a stainless steel tag on the outside of the device. But again, because it's Foundation Fieldbus, what you're able to do is you're able to register that tag internally, electronically on the device. This is very useful because what we find, especially on a lot of sites, is that they, when they do maintenance and commissioning, usually the tag is on a part of the device that can be removed. So in this case, sometimes we'll see it on the lid. They'll take 10 lids off, put 10 lids on the floor, and then when they put them back on the devices, they may put the wrong tag on the wrong device. But because this is electronic, obviously it stores that information correctly. And again, you can see there it's registered mic tag 1, which is what I've called this particular tag. And that's electronic, that's stored inside the device. So if we disconnect, reconnect, put it on a network, that will identify that product as mic tag 1. So that's just a quick overview of some of the features and benefits. In the next video, what I'm going to do is go a bit more in depth in terms of some of the parameters and some of the other things you can do with the AMX TREX within the Foundation Fieldbus environment and also within the TopWorx device from Emerson. Thank you for your time.